Alright, so section 1.2, points, lines, and planes. So this is all the basics of geometry. So first, let's look at this figure right here. So there's three different things in this figure. So there's a point, a line, and a plane. So a point is just like that one. It's labeled A. You just say A. You don't have to have a special symbol or anything. A line. So this line is AB, and you have to have these little arrows on top of them on the line to make sure it's a line, not a segment. So, or another way, you can just write a single lowercase l, because this L right here, that tells you that. So those are the ways of writing lines. You can write AB or BA. The order does not matter. A plane is a flat surface, so planes can intersect. So they have it's like, think of a piece of paper. It's a plane. You can pick it up, move it around. It's two-dimensional. It's flat, but you can draw an infinite amount of lines on it. Same thing with this. So you can either, if there's like this P is on there, you can name it, okay, it's plane P. That P is just to describe it. It's not a point. Another way you can do it is if you name 3 points that are not all on the same line. So you don't want that, but you would name it as plane ABC. Okay, let's do a little bit of practice. So what are two other ways to name the line QT? So QT is right here, and it goes all the way through. So let's talk about this diagram first. So we have a plane right here. We have a line RS that looks like it's on the plane. And then TN looks like it is going right through the middle, and it's going above and below the plane, but it looks like the only point that's actually on the plane is that Q. I'm just going to back up just a smidge more and show you, I forgot this piece. Points that lie on the same line are collinear. So linear means line, and points and lines that lie on the same plane are called coplanar. Coplanar is the same plane, collinear is the same line. All right, back to this. So what are two other ways to name QT? So QT is that line right there that goes through right here. So we have, you could of course switch around QT and say TQ. So TQ is one way, and remember you need your arrows on top. Can we use any other points? Well, yeah, you could say NT or TN. We're doing one extra one, that's okay. Either way, those work. You could also set NQ, QN. There's a bunch of different ways. So what are two other ways to name plane P? So plane P is that yellow parallelogram looking thing. So remember they said you can label it with 3 points that are on the plane that are not in collinear, so not in a straight line. So you could say plane would be VQR. That would be one option. You can switch those letters around, it doesn't matter. And then it looks like I didn't use S, so let's say plane QRS, and you could switch those around. There's a bunch of different options on what you could have said there. All right, what are names of 3 collinear points, or what are the names of 3 collinear? Remember that means on the same line. So it looks like we could do a couple different things. We could do RQS, that would be one. RQ and S are those points. Looks like you could also do NQ and T, whichever one you see first. And then what are the names of 4 coplanar? That means they're on the same plane points. But it looks like to me the only points that are not on the plane that are listed is this N and T. Those are not on the plane. So it looks like we can say the other ones. We would have point V, Q, R, and S. All right, moving on. So The terms point, line, and plane are not defined because their definitions would require terms that also need defining. You can, however, use undefined terms to define other terms. A geometric figure is a set of points. Space is a set of all points in 3 dimensions. Similarly, the definitions for segment and rays are based on the definition of points and lines. Okay, moving on. Here we go. We have segment, rays, and opposite rays. So a segment, it starts at one place. Right here, this one's A, and ends at one place. You can write it as AB or BA, but it has one line with no arrows. That tells you it's a segment. If it had the arrows, that means that would have arrows on there. So a segment just has a starting place and it has a stopping place. And that's it. A ray has a starting place and then it goes off infinitely into one direction. So whenever you do this, you write A, whichever the starting point is. It has to be first, and then it goes off until the second point. The second point can be at a couple different things if you would like. If there was another point and it was right here, you could have said point C. You could be like, okay, well this could be ray AC. That would, since they're on the same line, it would be the same ray, but you would have to say ray AC. Okay, the last one is opposite rays. So they share the same line and same endpoint, or they are on the same line, and so this would be like CA. CA would be a ray, and then CB would be the opposite ray. Alright, now let's do some practice. What are the names of the segments in the figure? So segments, remember they have a starting and stopping point, so we have DE, we have, looks like EF. You could also switch those around and say ED, FE, but I'm not going to. And then it looks like we also have DF. What are the names of the rays in the figure? So we have ray DE, ray DF. We could do FE, ED, a few more, and then we have the ones in the mid that starts at E and goes off in opposite directions. E, D, and E. Sorry, switch colors on you. My bad. Okay, and the last question for this section is, which of the rays in part B are opposite rays? Well, I just talked about that, so it would be ED and EF. Okay, moving on to the next page. Postulate or axiom. You're going to see these a lot. They're just a statement of facts, so they're like a theorem. So you'll see those two words both in geometry a lot. They've had proofs and they've been proven. So you'll use some of these later. You need to kind of start trying to remember as many as you can. So the postulate 1-1, through any 2 points there is exactly one line. So if I put 2 points anywhere, here's a point, I could draw a line through it. That's all that says, nothing fancy. Postulate 1-2, if 2 distinct lines intersect, then they intersect at exactly 1 point. So if a line intersects another line, they're going to intersect at 1 point. So AE and DB intersect at point C. Okay, so 2 lines have an intersection point. If they intersect, they intersect at 1 point. Okay, if 2 distinct planes intersect, so we're talking about planes now, they intersect at exactly 1 line. So this is huge. This comes up a lot. So planes intersect at lines. Let's write this up here. Lines intersect at points. Okay. Through any three non-collinear points, there is exactly one plane. We kind of talked about that on the other page. Points Q, R, and S are non-collinear. Plane P is on them and is the only plane that contains them. Okay. So let's go to this. Each surface of the box at the right represents part of a plane. What is the intersection of plane ADC? So it looks like that's the top one, ADC, and plane BFG. So that looks like this one, this side. Well, you can see, if you can't see it probably because I colored over a little bit, that would be a line. Remember, planes intersect at a line, so it would be a line BC. Or you could say CB. It doesn't matter. Okay. This part's kind of fun. So, what plane contains point N, P, and Q? Shade the plane. N, P, and Q. It looks like that bottom one. What plane contains the point J, M, and Q? Ooh, this one's a little funky. So J, M, and Q. Well, there is a plane there, even though it doesn't look like it's a side through this box. It's actually going to be a plane that goes right through diagonally of this box. So there is that plane. You can do that. And there are some homework problems like that. Alright, last part. What are the two names for XY, the line XY? Or what are two other ones? If you want to pause the video and try this on your own, try it. So you could say YX. Or it looks like there's an R in between them, so you could say RY. That's another way. You could say YR. What are the opposite rays? Well, that would have to be R is the endpoint, so RX. And then RY. What is the intersection of two planes? Remember, it's always going to be a line. So on this one, the line, you could say line SR or RS. Doesn't matter either way. Oops, what did I do?